Hi, I'm Chip, and today I'm going to show you how to make test cords for used dryer motors. You might be a service technician or a do-it-yourselfer that needs a benchtop motor that you pulled out of a dryer. If you stick around, I'll show you how to make a new plug for it. What you're going to need is an interface that plugs into each one of these motors. You can get these off of an old dryer, or if you're a hobbyist that you're building these, you want to wire these for like a benchtop tool. You would just go down to your washer and dryer repairman and ask him if you could get a pigtail off the wiring harness on an old dryer. Make sure you have the you can get motors from them too, but just make sure they'll plug into the motor. That's what you need to start with, and then you need to get two 120 volt leads. I cut this one off of an old washing machine, and I cut both of them off of old washing machines. That's basically what you're going to need. You'll need a crimping tool. I like to use inline splicers and some heat shrink. These are the typical dryer motors that you're going to find in most United States machines. This is the Whirlpool model type. You can find this in different models like Kenmore, Estate. Some of the Samsungs have them in it. This is basically just a dryer motor. Have different. The only difference is the length of the shaft and how they hook up inside a machine. This is a GE type style motor. Mainly, you can get by. A service technician can get by with just two different plug interfaces. These are the only things that change. And today we're going to be making test wires for those. Stay tuned. Okay, so the first thing we need to do is determine which wires we need to wire, because you've got 6 wires coming off of this pigtail, and you only have 3 wires coming off your plug cord. So we need to know which wires we need to splice in to make this motor operate. So on this motor, if you look here, we have this blue wire goes to a heat switch, out the heat switch into the windings. This purple wire goes directly into the windings, and we have this orange and white wire on this side which go into the windings. I figured out that the blue wire is the run windings, the purple wire is the start windings. Down in here it's got a weighted flywheel that when the motor spins up, centrifugal force throws the switch off. To energize it, we need to connect this lead, and this happens to be the ground right here. So the wires we're going to need, for a process of elimination, we don't need the element wire. We're going to keep the ground wire. We're going to keep the neutral wire. And this is your hot wire, and we won't be needing these two. So we've eliminated everything but the hot, the neutral, and the ground. So these are the 3 wires. These are the 3 wires we'll hook to our test lead. Okay, we're going to use 3 inline splices to connect these wires. We're going to connect the neutral, and the black and grays are going to be the hot, and we'll use the greens for the ground. Always bring your trusty pocket knife. Very good. Now, put our heat shrink over the top. Leave it all together. Now we're going to use our heat gun. And there we have it. All over but the testing. So let's plug this in. And contact. Looks like a charm. Now let's move on to the G model. Okay, on this G motor we have a little different situation. It's not that different. You have a ground, the blue wire, the hot wire's in the middle, and the neutral ground, wire is on the right side. So what we're going to do on this plug, these 3 wires here are not going to be used because they go to the timer and to the element. So we'll just clip them off, and it would be better to pull these connections out, because once the motor spins up, one or both, or all 3 of those wires can be energized at one time. So what we'll do before we complete this job is pull these spade plugs out of here with a punch or something. We'll have to get a pick and pull them out of there. But these are the 3 wires that we're going to be dealing with, and I'm going to cut them all same size and strip them back, and once I have them stripped, we'll strip them together and go from there. Okay, now I have them all stripped back nice and pretty and twisted together, and I've already crimped 3 connectors onto my plug, and I've already put a sleeve of heat shrink on it. And don't be like me and put them all together and not have your heat shrink already on the cord. So here we go. Let's put these together. So we'll do the ground first. test it. Let's shrink wrap it. Good deal. Now, bring our motor over and plug this in. And we'll give it the test. Contact. Perfect. There we have our testers. Now washing machine motors are different. They take a capacitor to start them, but I have a box that I've made that has a switch in it. You can test forward, reverse, and I'll make a separate video on how to do that with the schematics and everything. That's a real handy tool to have to see if the washing machine motor is functioning correctly. But thanks for watching, and I'll see you in the next one.